Hi guys, this is 2023 AMC problem 17, and we have this problem that seems like a sort of 3D geometry problem here, but I think it's actually like spatial kind of visualization problem where you just have to imagine how this 3D shape would look when it's fully constructed. So it says a regular octahedron has eight equilateral faces with four faces meeting at each vertex. June will make the regular octahedron shown on the right by folding the piece of paper shown on the left. Which numbered face will end up to the right of Q? So um, I think that we should just start by imagining it piece by piece. So here we see that Q is facing upward in this position, right? And we want to know what would be next, right? So to the right on the net, to the right of that upwards facing Q, we don't have anything, so we really can't determine this yet. But to the left, we have this six, right? So we know that this six will probably belong here, and it'll be pointing upwards, right? The top of this will still be pointing upwards because it shares this edge, right? I mean, not upwards, it'll be slightly tilted with the head pointing to this side, right? And then to that side, we'll have seven, right? Because this is still oriented in that way, where it's sort of facing outward right now. And we have seven on this other side. So if we had something here, we would know what's over here, but we don't. So like right now, I've just imagined it as this sort of net that folds into this sort of shape with six in the middle and Q like this and seven. And you can imagine how that would fold out to look like this, right? And then let's see, what can we figure out next? Well, we have nothing attached to seven and Q, so we can only look at five here. And five shares this border with six. So I think five will be down here. Um, Actually, it wouldn't be, we know it wouldn't be in this orientation right now, especially because we know that it's facing outwards. This five would appear facing forward on the other side of this piece from what we can see, right? So our five is here, and to um, for the next triangle, we would know that on this other side of five, we would have four, right? So this is five and this is four. And on this other side of five, we can imagine that six is here and this is five. Like imagine it from the other side. This is five. And five shares this edge with six and this edge, right? This edge with six and this edge with four. So four would be here below seven, right? This would be four. So four back here. And then on the other side of four, right? So we shared this edge. And on the other side of four, I believe that we would have our three, right? So let's pretend we turn this over. So right now we know it's like seven above, six over here, it's five here. And sorry, this is poorly drawn. They should be sharing an edge. Um, it would be um five here and four here. And we know this edge is being shared with five. And this edge, like if we would turn this so it fits there, is shared with seven. So this edge should be shared with three, right? So another side would be here. And now all we have left is our one and our two. So currently, this side is the one being shared with four. And it's the one with, let me rewrite this real quick. It's the one where three is sort of facing downward like this, as you can see, with like three, the back of three facing this part, right? So in the front of three, we would have one. Actually, this is poorly drawn. It should be so to the top of three, we have four. So it should be actually on this side. So three should be facing this way with the back of three facing four. And then we would have on like the front of three is facing one and the back of three is facing two. So this should be 1 here. Sorry, this is all a little bit confusing since it's difficult to draw these um like three-dimensional things on a one-dimensional surface. But if you really imagine how all of these numbers would be oriented and which edges would be shared, I think you will come to the answer 1. So our answer should be A. All right, thanks guys.